Hello, seventh grade. Today we're going to be talking about a interesting subject, especially for those of us that enjoy watching sports. That is called experimental probability. Experimental probability. So we've talked a little bit this year about what's called theoretical probability, and I want to make sure you guys know this is not that. So there's the theoretical probability, and how you find that is with just pure math. You say, well, there's a 50% chance this thing's going to happen because I did the math for it. And theoretical probability is really nice, but a lot of times we don't have that. So we're not going to be able to use it, and experimental probability is what we're going to be going with. So what experimental probability is probability that you find by using an experiment. Hopefully we caught that just looking at the title, but if not, that's okay. What we're doing this lesson is we're going to take data from experiments, and we're going to use that to find probability. A quick example of that would be if we have a baseball player. I know there's some people in the room that like baseball, and what would happen is, let's say that our baseball player friend goes at bat 60 times. And of those 60 times, we are going to say that they hit the ball 21. So our experimental probability would be that they hit the ball 21 out of 60 times, which is going to be equal to 0.35, or in baseball you would write that as a 350 batting average. And this is pretty much what we're going to be working with today. So our formula for this, I'll go ahead and write that down. Formula is always going to be the number of times an event occurred. In our case of the batter, that event would be hitting the ball, divided by the number of trials we did. So that's how many times we tried to get that event to occur, which would be the at-bats, number of trials. And we can use this for basically every situation we're going to see where we have experimental probability going on. We're going to take the number of times an event that we wanted to happen happened, and then we're going to divide that by the number of trials. So another example of this would be if we have someone, let's say that they work at Sam's Club and they're handing out free samples at Sam's. I love those people. They're my favorite. And let's say that they have 50 people take a sample, and 30 people not. Well, what we can do now is to figure out what the probability someone will take a sample is. Is to plug it into our formula here. Probability sample is taken is going to be the number of times the event occurred divided by the number of trials. So the number of times our event occurred, what we want to happen is the sample is taken. And that happened 50 times. I'm going to write that on top. And we're going to divide that by the number of trials. So how many times did they try to get someone to take something? So that's going to be a total. Let me make that a little more clear. The number of trials is always going to be a total between our failures and our successes. So 50 plus 30 here would be 80. And 50 out of 80 is going to be 0.625. So 62% of the time, then we are successfully getting people to take these samples and giving them free food and happiness and joy. Something that might be important to note as we do this, let's pretend that we're going to do a bit of a thought experiment here. One of Einstein's favorite things to do is thought experiments. Let's say our favorite theoretical probability questions, the ones to do with math, are like having marbles in bags and taking them out. So in my thought experiment, I'm going to have a bag, and we're going to have marbles inside this bag. I'm going to have just one red marble and one blue marble. And as we go through, I can take out one marble, put it back in, take out a marble, put it back in, and we can count how many of each we get. So after one trial, I'll write this as trial, blue marbles, and red marbles. After one trial, I'm either going to get a blue marble or a red marble. Let's say I get a blue, which means I haven't gotten any reds. So the percent blue is what I'm going to look at, would be 100%. After 2 trials, let's say I get a blue again. It's all right. My percent's still 100%. Then after 3, I get a red. We're at 60%. Really 66. Let me change that. 66%. And as we go down, what's going to be happening here is this number will always be approaching the theoretical number. So the theoretical number of times you should draw blue would be about 50%. This is telling me we should get about 50%. And as we go on, if we do this forever, this number right here will eventually get to 50. Let's say right now I go ahead on trial 4, I get another red marble, and I'm at 50%. Whatever I get next is going to take me away from 50%, which is kind of sad. So let's say I get another red. Doesn't really matter. Either way, I'll be taken away from that 50% a little bit and move either to 40 or 60. But as I go more and more, we can see that the amount that this is changing off of 50% is getting less. So 66 is further from 50 than 40 is, if that makes sense. So 66 is 16% away from 50. 40 is only 10% away. So with this, even though they were both one off, our percentage here is closer in the later trials. So the more trials we do, the closer our experimental probability is going to be to our theoretical probability. So more trials is always better. More trials is always better. Other than that, this is pretty much all we're doing today. So the practice set has 5 whole questions for you all to work on. I know that's going to be such a drag, 5 questions. But what you're going to do in all of those questions is we're going to use this formula right here. Very important formula to figure out the number of times an event occurred divided by the number of trials, and that will give us our experimental probability, and we will be good to go. Other than that, I will see you all in class. Toodaloo.